Yes, guys. So today I'm talking about differential equations. Next subject I've taken here, I mean in mathematics, applied mathematics. This is applied mathematics here. Okay, differential equations I've taken. Today is the first lecture of differential equation. First of all, we will talk about what is definition of differential equation. Then the basic definition regarding order and degree of a differential equation. Okay, so first I'll just describe it what definition of differential equation, what are the differential equations, or what is a differential equation. Then what is order of a differential equation, what is degree of a differential equation. I've taken these questions from students' queries. Okay, as I always take the students' queries. Okay, so these are the queries of the students, some of the queries. In the next lecture series also I'll take further degree and order of the differential equations and how they are calculated. Sometimes the equations are given in which fractions and rational fractions are given, radicals are given. Okay, so we have to make them free from the radicals or fractions, and after that we have to find out what is the degree of that equation. That I'll talk about. But before that, let me take definition of a differential equation. And these are the questions, 25 questions I've taken here, and they will just describe, and definitely I'm 100% sure that, as my students say, that's now clear. It is clear that degree and order, what is the degree of a differential equation, what is the order of a differential equation, we can now recognize very easily. So that is the main objective of mine, just to clarify the students' doubt, or all those people who want to learn what is the differential equation, what is the degree, and how to find out degree and order of a differential equation. Because most of the questions in the beginning they are asked about order and degree. Okay, so for engineering students, for all kinds of students who are studying mathematical science or science, okay, or mathematics, applied mathematics, mostly for engineering students, science students, arts students maybe, but they are studying the mathematics maybe at graduation degree, post-graduation degree, or even at intermediate colleges. Okay, so for those students it may be beneficial. Now let me take for the definition of a differential equation. So now let me first verbally talk about it, and then I'll note down here that any equation, okay, an equation which involves or which includes, okay, dependent variable, independent variables, and differential coefficients or derivatives or differential coefficients of dependent variable with respect to independent variable. Okay, those equations are known as differential equations. So a differential equation must involve independent variable, dependent variable, as well as differential coefficients. And these differential coefficients are calculated or described in terms of when dependent variable is differentiated with respect to independent variable. So those kind of differential coefficients or derivatives are included in these equations. So those equations are known as differential equations. Okay, it's a definition basically, and some say simply definite. There are different derivatives, definitions, but this simple definition that an equation which involve derivative, undoubted derivatives are there, differential coefficients are there, but these differential coefficients are described in terms of dependent variable and independent variable, and derivatives are expressed when we are finding out derivative or different coefficient with respect of dependent variable with respect to independent variable. That is the point. That is the derivative. So those derivatives are there, okay, and dependent and independent variables are there. Those equations are known as differential equations. Okay, or simply we say that an equation which has one or two or more than one or two, okay, at least one derivative or differential coefficient, that is a differential equation. Differential equation must have derivatives, must have differential coefficient, okay, or derivatives. Okay, so that is the at least requirement of a differential equation. What is the at least requirement? That it must have at least one derivative, one differential coefficient. Other things are there, undoubtedly independent variable will be there, dependent variable will be there, but dependent variable, in spite of dependent and independent variables, they are expressed in dependent and independent variables, but at least one derivative must be present there. Only then that equation will be known as differential equation. Okay, so let me describe and how order and degree are to be calculated, that I'll just describe. So first let me define that what is differential equation. So an equation which has or which is expressed in terms of which has dependent variable, which has dependent variable, comma independent variable, independent variable, and differential coefficients. Let me describe it. And differential coefficients. Okay, differential coefficient expressed with dependent variable, differentiated with respect to independent variable, differentiated with respect to independent variable. I'll talk about that. What is independent variable? Independent variable. That equation is a differential equation. An equation which has dependent variable, independent variable, and differential coefficients expressed with dependent variable differentiated with respect to, expressed in terms of dependent variable differentiated with respect to independent variable. Okay, expressed in terms of, let me write here, in terms of dependent variable differentiated with respect to independent variable is known as, or is called a differential equation, or is called a differential equation. Is called a differential equation. So what is the requirement? Note here. First thing, it must have at least one differential coefficient. Only then we will say that this is a differential equation. At least one differential coefficient. One thing. There is no doubt that it is expressed in terms of dependent variable and independent variable. Independent and dependent variables are always there. There is no doubt about this. Are always there. Since derivative or differential coefficient is expressed with dependent variable in respect to differentiated. Okay, with dependent variable differentiated with respect to independent variable, this is there, independent variable, this is there. Or simple definition, an equation which has differential coefficients is known as differential equation. Differential coefficient, different or derivatives are there in an equation. That equation is a differential equation. But dependent independent variables are there. They are understood. They must be there because derivatives are expressed in terms of dependent and independent variables. Okay, so only we can say that an equation which is having derivative or differential coefficients, at least one derivative is there, one differential coefficient is there, that equation is a differential equation. Differential equations are equations which are having derivatives or differential coefficients, where the dependent variable is expressed in terms of is differentiated with respect to independent variable. Dependent variable, for example, let me take now instances or examples. Okay. Now, for instance, or for example, let me talk about. Okay, for instance, let me talk about. First one, if I take d by dx plus 3x plus 4y equal to 0. Maybe equation is a differential equation. This is differential equation because one derivative is there. This is first order derivative. Now I'll talk about order and differential. Second example, if I take d square by upon dx square plus 3 d by dx plus y equal to 0. Sometimes it is there. Okay, we can just say this is a differential equation. Okay, differential equation. This is third one. If I take d by dx whole square plus d square by dx square plus y equal to 0 or plus 3y equal to 0. Any number. So this is differential equation. It is having derivatives. This is derivative. This is derivative. This is derivative. Derivative. One, at least one derivative is in this first one. This is second one we are taking. So these illustrative examples. Okay, we have taken illustrative instance. So these instances I have taken. They are described. These are the differential equations. The differential equation must have. This is now I have taken y here dependent variable, x is independent variable, y dependent variable, x independent variable. Again, y dependent variable, y is differentiated with respect to x. In the denominator we are having independent variable. Y is differentiated with respect to x. X is independent variable. Y is dependent variable. Okay, so y dependent variable, x independent variable. In all the three equations, we have taken y as dependent variable and x as independent. If it is dx upon dy, okay, dx dy, this is dx dy. In this situation, y is independent variable, x is dependent variable, x dependent on y. This equation is expressed in terms of, this derivative is with x dependent variable, y independent variable. Similarly, we take ds dt. This is a derivative where s is dependent variable, t is independent variable. In this way, dependent and independent variables are expressed. So, an equation which is having a derivative or differential coefficient in which one dependent variable is expressed with respect to independent variable. Okay, so this is what dependent independent variables are there. Now let me talk about what is order and degree. And simply we can say that our differential equation having differential coefficients is known as differential equation. An equation which is having derivative or which is having differential coefficient is known as differential equation. This is the definition of differential equation. Simply we could say that an equation, if I say an equation, this is simply an equation having differential coefficients, or expressed in terms of differential coefficient, expressed in terms of differential coefficients, is called or is known as differential equation. Simple. So this is a simple definite differential equation. This also we can say differential equation is there. Undoubtedly, differential equations are, or derivatives are having independent and dependent variable, dependent or independent variables. That is must. Without dependent and independent variables, derivative cannot be written or cannot be expressed. So in this way, dependent and independent variables are understood. Okay, but they can be expressed at an equation which is having dependent and independent variable as well as derivative. Derivatives are must. Okay, at least one derivative, as I have just expressed, but at least one derivative must be there. Only then that equation is a differential equation. That is the basic definition are taken into base. Now let me talk about order and degree, which is the topic of today of these equations. Here I have taken find the order and degree of the following equation, following differential equations. All these differential equations are there. We have to find the order and degree. Now first let me express what is the order. Order of it. First point is what is order of a differential equation? What is order of a differential equation? That is the point. Now if I just talk about order, now we know that when differential coefficients are found out, are calculated or are expressed, okay, derivatives are expressed, differential coefficients, if we talk about differential coefficients are expressed like d by dx, okay, comma d square by dx square is like dq by dx cube, comma d4 by dx4, okay, and etc. dn by dxn, or we can express dxd by, comma d square x d by square, dqx d by q, and so on, and dnx on d by n, etc. Now what is the order here? Now this is first order derivative, first order differential coefficient, second order d square by dx square. This is second order, third order, fourth order. This is nth order derivative. Now here first order, here difference only in these two are, here x is the dependent variable, y is independent variable. Here y is a dependent variable, x is independent. This is the only difference between these two derivatives. Okay, so this is here y dependent variable, x independent variable. Here x is dependent variable, y is independent variable in this expression. Then orders. What is the order? Order is the, you may say, if any derivative is expressed in 2 times, 3 times, this is second order derivative, third order derivative. This is fourth order derivative. Okay. This is the first order, second order, third order, nth order. The order is the, we can say, the how many times that derivative is expressed. Okay, so this is, as I just told you, that this order is, what is the order of a differential equation? Now let me express the order of a differential equation. So the order of a differential equation is the highest, you may say, highest order or highest times, highest order of the differential coefficient differential coefficient which is expressed in a, okay, so the order of a differential equation is the highest order, is the order of the highest order, is the highest order of the differential coefficient which is found in a differential equation, which is expressed in a differential equation. Expressed or found in it. This is expressed or found. So highest order of the term of that derivative differential coefficient, which is expressed or found in a differential equation. Now let me talk about this thing in a differential equation. Okay, for instance here, let me talk about. Now d by dx plus 3y plus constant equal to 0. Okay, now in this case, this is the highest order, means only one time. This is order is 1. The order of this is 1 of this differential equation, but this is the highest order of the term which is having differential coefficient, which is only one time derivative, d by dx, not second time, third time, fourth time. Okay, so this is first order derivative, first order differential equation. Sorry, order is 1. Here, order is 1. If I express dq by dx cube plus d square by dx square plus d by 3d by dx plus 5y equal to 0. For the order, we choose that highest order derivative, highest order term, which is the highest order. Means this is the third order derivative, this second order derivative, this first order derivative. But we will take the highest order derivative, the term which is having highest order. This is the third order derivative. This is third order derivative. Order is 3 here. Order 3. Number of terms are there. Here it is second order, first order. But the order of this differential equation is 3. So we choose the order of that highest derivative, which is found in a differential equation. In a differential equation, the highest order term, the highest times differential coefficient is known as the order of that differential equation. This is the highest order term. This is second order. This is first order. This is third term. 3 times. So this is 3 order derivative. Third order derivative. This is the only term. So order of this term is known as order of that particular differential equation. This differential equation is having order 3. Okay, so this is next one. Now let me talk about one more instance. If I take, this is dq by dx cube plus 4 d4 by dx4 into, okay, whole square. If I take plus 5 d by dx whole cube plus y equal to 0. No problem at all. Now in this case, the highest order derivative term is this. This is fourth order. This is third order only. This is first order. The order is 4. The order of this equation is 4 here. So this term is having highest order derivative, which is 4. Order of this equation is 4. Order is 4 here. So order means order of a differential equation is the order of that derivative, that differential coefficient, which is found in a differential equation. The highest order of that term, which is found in a differential equation, is known as order of that differential equation. So this is order of a differential equation. I'll just take these questions, but before that, let me express that what is degree of a difference, which is very important to know. So there is a difference between order and degree. Well, let me talk about degree. Degree of a term, sorry, differential equation. Degree of a differential equation. Of a differential equation. Degree of a differential equation. The degree. Now, in case of degree and order, there is a minor difference. That in this case, what is the order? Sorry, degree. The degree the degree is the power of the or index of the highest order derivative. Highest order differential coefficient or derivative. Let me find that derivative or differential coefficient. Differential coefficient found or find in a differential equation free from radicals and fractions. Differential equation. Differential equation free from, the differential equation must be free from radicals and fractions. That is the most important one, radicals and fractions. The differential equation must be free from radicals and fractions. The differential equation is free from radicals and fractions. Then we find out what is the highest order derivative. Okay, so highest order derivative is having some power. What is the power of that highest order derivative? After expressing that radical or fractional differential equation, when we have converted this into proper polynomial, where polynomials are expressed in terms of differential coefficient, where terms of the polynomial are differential coefficients, maybe variables or dependent variables, independent variables, but derivatives are also there. So polynomial, when a proper polynomial is formed without any fraction or radical, or is free from radicals and fractions, that equation, differential equation. Now we have to think about what is the power, highest power or power of the highest order derivative. Then we calculate. So that order is known as, that power is known as degree of that equation. Now let me take some instances here. Okay, so that will clarify this point. Let me illustrate what is degree. So for degree, let me take some instances here. Degree of a differential equation. So for instance, let me take, now here we have taken a polynomial which is expressed in terms of differential coefficient or derivatives, which is free from radicals and fractions. That is the point. So a differential coefficient, differential equation, let me write here. A differential equation free from radicals. This is the most important point. Free from radicals, because sometimes students are just commit errors in case they are not removing those radicals and fractions. They are just calculating that this is the degree and all. But first we have to make that polynomial, free the radicals and fractions found in our differential equation. We have to remove them first. We have to express that differential equation in a proper polynomial form. Okay, so let me just, a differential equation free from radicals and fractions, okay, will have some power, of a highest order derivative in that equation. That highest order power of this will have some power of the highest order derivative in that equation is, or that power of the highest of the highest order derivative derivative is known as degree of that equation. Is known as degree of that equation. I'll just take some instances here that will clarify. Okay, as degree of that equation of that differential equation. Okay, now for instance, let me now take some instances here. Okay, for instance, okay, if I take, sorry, the smaller one, let me take, this is dq by dx cubed plus 5 d square by dx square plus y equal to 0. First, I'll just find out what is order and degree of this equation. You'll just calculate. We are now talking about degree. I'll talk about. Okay. Then d square by, this is second instance, plus d by dx whole square plus 3y equal to 0. Maybe this is the instance here. Then d square by dx square whole cube plus dy upon dx whole 5 plus 6y equal to 0. Then we have d square by upon dx square plus dy dx divided by d square by upon dx square, okay, plus constant, or let me take y here, or let me take 5y equal to 0. This is very interesting. Let me now express them. What is degree of this equation in this case? Now first we search that what is the order of that equation. The highest order term is this one. This is 3 order derivative. What is the power of this? We find here that this is only third order.